Okay, rocks and minerals. First off, I want to say the key thing about minerals and rocks, and the best part, is the hands-on part. Getting them in your hands, you know, the minerals, rubbing it on the street plate and scratching the glass with it. And I have some videos for the lab practical, the Part D, that actually show how to do that. So those are included. Make sure you watch those. This we're going to do here is a little more the information behind it and answering some questions using the reference tables. So here we go, minerals. First of all, chemical elements make up minerals, and minerals make up rocks. So let's look at chemical elements a minute. So this is the front page of the reference table right here. At the bottom, there's a chart with chemical elements. And this is what we see. How this relates to minerals is right here. The crust of the earth, meaning the rocks of earth, are right here. So, and it's broken out by mass. You can think of weight is in this column, and you see some of the elements here: oxygen, silicon, aluminum, iron. And this column here is by volume, and that's how much space they take up. So make sure you're always looking in the proper column. That can be confusing. Okay. And then these elements can relate to minerals. If you go to the back page of the reference table, the very back page, page 16, this is the composition of all of the minerals, and it is those chemical elements from the front. So oftentimes you need to use those two charts together, so be aware of it. Now, here are some properties of minerals. They are things like luster, hardness, how it breaks, cleavage or fracture, color. Those are just some of them. And the properties of a mineral are due to its composition, what chemical elements it's made of, and also the atomic structure, which is how those elements are bonded together. I like to think of it like this. Here I have some Legos in this container here, and the loose Legos, we're going to call this, this is the composition. The individual Lego pieces are the chemical elements, and the atomic structure would be how you actually put these together, how you connect them. So you could connect these in a lot of different fashions, a lot of different patterns, and therefore get very different looking structures. So that is similar to how minerals work. And here is an example of the atomic structure of a mineral called kaolinite. And so this shows the structure here and how they're bonded. And again, this is a key component, key reason why minerals have their properties, the atomic structure of that mineral. So let's look at luster. For us, luster, there's really two types. What we're interested in, either metallic or non-metallic luster. Now, for metallic, you really want to ask the question, does it shine like silver or gold? If it shines like silver or gold, or even just it's considered metallic. If it doesn't, it's non-metallic. Where we see this in the reference table is here. The reference table is really, first it's broken out in metallic ones here and non-metallic here. Okay, and it says it at the top under luster. Hardness is another property, and that's the resistance to being scratched. Not broken, scratched. Where we see that in the reference table is here, and we use the Mohs hardness scale of 1 to 10. The higher the number, the higher the hardness, and the more it resists being scratched. Diamond is the hardest known substance. That has a hardness of 10. So that is here, and then it goes from low to high within each metallic or non-metallic. So for instance, fluorite has a hardness of 4 on the scale, okay? Sulfur has a hardness of 2, and quartz has a hardness of 7. This is my example. So therefore, the mineral fluorite can scratch sulfur because it's lower, but it cannot scratch quartz, okay? But quartz can scratch, if you rub it on fluorite, it will totally scratch fluorite, it will totally scratch sulfur because it has a higher hardness. Quartz will also scratch other quartz if that was to come up. How it breaks, two choices, cleavage or fracture. Cleavage is going to break with some kind of an orderly pattern, and maybe it has flat sides, any kind of angles, looks like steps or anything like that. Any kind of order is going to be cleavage. Fracture is random breaking, bumpy surface. You see no order or pattern to the breaking. So this picture here is from a Regents exam, and it shows a really, really good example of cleavage. This was one piece, hit it with a hammer, and it breaks into these cubes. It looks like it's been cut, but it hasn't. Now, this is a really, really good example of cleavage. Not all cleavage is this clear and obvious. Okay, now where we see that in the reference table is here. It's with these check marks, cleavage on the left, fracture on the right. You often need to use that as well. Uses is in this column, and sometimes that's just some sort of straightforward questions if you know where to look at it. It says, what mineral is often used for pencil lead? And that would be graphite, because that's right there. So sometimes you refer to that. Those questions, if you know it's there, are usually pretty easier types of questions. The composition as I pointed out, for each for the minerals are listed here, and often referenced at the front. At the bottom of the page, they have some of the element names here, so know that that's on there as well. So here is a question, and it has these two minerals here. The crystal shape and type of cleavage of these two minerals are determined mainly by the minerals' composition and atomic arrangement. So it gives you an example of some questions that may come up on this. Here's another one. Identify two elements that can be found in both olivine and pyroxene. So you need to go to the last page of the reference table and look under composition. So here, right here, I'm gonna zoom in here. Okay, so we are interested in pyroxene and olivine. So you want to give two that are in both of them. So I'm kind of looking through their compositions here where they match up. Well, they both have iron. That could be an answer, which is Fe is iron. It's on the bottom of that page if you need to look it up. They both have Mg, magnesium. They both have Si, silicon. And they both have oxygen. So any two of those four would work as an answer, but you have to know there to look. Here's another one. What mineral will scratch fluorite, galena, and pyroxene? We'll scratch all of them. So we're looking for something that is harder, higher hardness than all of those. Here are our choices. So let's go to the reference table. Galena has a hardness of 2.5, fluorite 4, pyroxene 5 to 6. So we need a mineral that is going to be a higher hardness than 6, because that's the hardest one of our minerals of our of what they're given to us. Here are our choices here. These four, I put them in red. Okay, so we're looking for what has a higher hardness, and it's clearly going to be olivine. Olivine is hard as 6.5, so it can scratch anything that is 6.5 or less. So the answer should be olivine right here for that question.